Saxon Algebra 1, Lesson 107. Today is a glorious spring day in the Pacific Northwest. I've got a little bit of spring fever, I'm not gonna lie, and I get excited when I see Lesson 107, and I'll show you why. There are 120 lessons in this book. Oh, look, I haven't crossed off in a while. We are getting there, you guys. We are talking about 3 more weeks of new material, a final exam, and then we are free for the summer. Yay! It's so exciting. I'm excited for you. Honestly, I could do this every day. I just love it. But I know that your brains need a break. And so I'm happy that we're almost to the point where you get one. Okay, we are going to talk today about slopes. We're talking about equations of lines, right, that we can graph, y equals mx plus b. And we're going to talk about 2 specific types of problems. And it's pretty straightforward. There's not a lot of drama in this lesson. We're going to use this thing that we call slope formula. You've seen it before. It looks like this. We say that in order to find the slope of a line, you can take any 2 points, arrange them like this, and you can solve for it. Remember that m equals the slope of a line, right? Positive slopes go uphill, negative slopes come downhill. But this is the formula that we'll be using sometimes in this lesson, but we've got some other tricks so that we don't always have to use this formula, okay? Sometimes we use the formula, but here are 2 times when we don't have to. In the first situation, which is part A, we are going to learn that parallel lines, look, I forgot the L, have equal slopes. And let's just take a look at that because it's an interesting idea. And we don't even have to graph them. We're just going to draw some parallel lines. We can see just by looking at this that these 2 lines are running, I mean, pretend it's perfect, right? They're running at the same angle, and they will continue to do so to infinity in either direction, right? I mean, let's be honest, mine wobble a little bit, but you get the idea. If this is our line, and we're told that this is a parallel line, and then we're told that the slope of the parallel line equals whatever, minus 5/3 or whatever you want it to be. This would have to be a positive one, wouldn't it? But if we're told what the slope of the parallel line is, then we know that the slopes will be the same. It makes sense, right? They look the same. They're crossing the y-axis at different points, but the angle is exactly the same. So that's going to be the style in several problems, is that we're going to be told, here, find the slope, find the equation of our line, P.S., here's the equation of a parallel line. So let's try that. We'll start with example 107.1, and let me read it to you. Find the equation of the line that goes through -1, -3, and is parallel to, and then they give us a whole equation here, 4x plus 3y equals 7. All right, well, we've got plenty of information here. We can use this information to find our slope. Did I spell that wrong? No, that's right. You know how sometimes if you look at a word too long, it'll just look wrong? Parallel is doing that to my brain right now. Okay, so we have to figure out the slope of this line, and then we can copy it because we know that parallel lines have equal slopes. So what we have to do is fix this because we need this to be in the proper format, right? This line is in what we call standard form. We want it to be in slope-intercept form. Slope-intercept is cool because we can graph it just the way it is. That's the advantage of it. Highly graphable. This, I mean, in some situations, like if we were solving for a system of equations, we might want it exactly like this, right? Because then we could eliminate the x's or the y's. This could be perfect in a different scenario. But when you're talking about graphing lines and finding the equation of lines, we want to mix this up. So what we want to do is we want to solve for y equals mx plus b. So that's our first step. And remember, this is the other line. I'm going to add that to this. Solve the other line. And I use the language, John doesn't always, but we use our line to describe the problem we're trying to solve, and we use the other line for the line that's going to give us information. So I'm going to flip the page, and I'm going to take 4x plus 3y equals 7, and I'm going to solve it for y. So it's in this form. All right. 4x plus 3y equals 7. I'm going to subtract the 4x from both sides. That's going to give me 3y equals minus 4x plus 7. A little tingle, a little chill runs down my spine because I'm thinking ahead and going, when I divide this by 3, I'm going to get 2 wicked fractions. I don't care. I'm just playing with the numbers. We're not going to graph this, so don't let that sweat you. We have to get the y by itself, so I'm going to divide all the way across here. Now, we find that the equation of the quote-unquote other line is y equals minus 4/3 x plus 7/3. This is, I'm going to just write it again so we're clear. This is the other line. It's the line we're using for information. We know, because I just told you a hot minute ago, that the slopes of parallel lines are the same. So, this slope is also our slope. It's going to be negative minus 4/3. Yay, you know what that means? We're halfway to finding the equation of our line. Okay, so the next step, the first step was to solve the other line for y equals mx plus b, right? The second step sorry, lots of words. We're going to use this slope, which is the other line slope, which is now our slope, and we're going to use that pair of points that John gave us way back in the beginning of this problem, which is -1, -3. I'll write it again. John gave us this. We did not figure this out. We're going to remember that this is x, this is y, and this is m, right? Our slope, we can call it m. We're going to plug that into the equation of our line and solve for b. So watch what I do. I'm taking this, right? Y is -3 equals m is here, -4/3, times x, x is -1, plus b, that's our mystery man. That's what we're solving for. See how I just plug the values that we have? This we figured out from the other line. This we were given. We plug them in y, m, x, and then we're left with b. And now all we have to do is solve it. Remember when solving something like this was the whole problem? Now it's like one tiny baby step, right? In the whole thing. All right, these two multiply. This is going to go to +4/3, right? So I'm going to draw a line through that, and I'm going to make that say positive. Now we need to subtract 4/3. That'll make b by itself. In order to subtract this, I have to change this into a number with a 3 on the bottom. So I'm going to multiply top and bottom by 3. It's going to become minus 9 over 3. I can draw a line through that. Minus 9 over 3 plus minus 4 over 3 is minus 13 over 3, right? That's this side, equals, this now cancels, right? Plus 4/3 minus 4/3. That's all gone. B. We did it. We solved for M and we solved for B. We did not have to use that slope formula this time. All I have to do is write my answer. I'm going to write it way up here because this is where I have space. Our final answer, the equation of the line we're trying to find, is y equals minus 4/3 x minus 13 over 3. That's the equation of, quote unquote, our line. That's the right answer. We took the slope from the quote unquote other line. Parallel lines have the same slope, so we took advantage of that. And then we plugged that slope and the pair of points we were given into our old friend. We solved for B, and then we took our two pieces and wrote it in y equals mx plus b format. Oh my gosh, that wasn't so bad, was it? Let's do one more. One more? No. That's all for this part of the lesson. This was how we used a parallel line to help find our slope. Now, in a weird twist, John is going to now give us easier problems. That was the harder part of this lesson. Ready? Example 107.2. Here, let me just give this a title. B, these are lines with a given slope. And what I mean by that, I'm leaning hard on the quotes today, aren't I? John's just going to tell us what the slope is. So we don't even have to do the work that we did last time of, remember how we had to rearrange the equation to get it in slope-intercept format, and then we had to take that slope and make it our slope? John's not going to even put us through any of that. 107.2. P.S. Don't speed up my videos and try to make sense of them. Don't watch them on accelerated speeds. Please, I beg you. It is such a waste of your time. I watched a few videos over the weekend of this past weekend, accelerated. No, it messes with your brain. It is not, I know it takes less time, but you're wasting the time that you're putting into it. Well, anyone is, I'm not saying you. Because it's too, our brains cannot absorb information at a faster speed. My gosh, this is bad enough going slow, right? But if you accelerate the speed of the video, your brain cannot process human language being shared at that same rate. Not just your brain, any human brain. It has nothing to do with being a teenager or anything like that. It's not possible for our brains to process at that accelerated rate, and you're just wasting your time. You're not going to understand it as well as if you just listen to it. So please don't do that. Okay, ready? Find the equation of the line that passes through the point. Oh no, it's not negative. It's just 3, 4, and has a slope. Here's where I saw the minus sign. Of negative 3 over 4. John's just telling us, use that as the slope. So we go, okay, that's the x, that's the y. We don't need to solve for m, so we're ready to take the information we have, which was the second step of the last problem, and we plug this stuff in. We say 4 equals minus 3 over 4 times x, which is 3, plus b. See? We just plug it in again. Y, m, and x. Y, m, and x. This is one of the weirder lessons where the second part is easier than the first part. Now all we need to do is clean up the math. This becomes minus 9 over 4, right? So we have to add 9 over 4 to both sides. Right? Minus 3 times 3 is negative 9 over 4. So I changed that into this, and then I added it to cancel it out. This is a 4, but it needs a 4 on the bottom, so I'm going to make this 16 over 4, right? I multiplied top and bottom by 4 in order to get this. This then becomes 16 plus 9. I made a very strange 2. 25 over 4. This all cancels, equals b. And so the equation of our line is y equals minus 3/4 x plus 25 over 4. Again, that would be gross if we had to graph it, but we don't. Let me just double check. You guys, it's so frustrating and annoying to me. Every once in a while, I find out that I made a dumb little mistake in a lesson. Oh my gosh, it makes me want to scream because my poor students have to see that mistake and go, wait, why did she do that? And they can't ask me and they can't tell me I made a mistake. It's so sad. So I'm sorry. I apologize for any dumb little mistakes you might find in here. I'm trying really hard to get them all out. Each year as I redo my lessons, right? I just think, oh, please don't make any mistakes. Okay, let's do another one. There are 2 more. Find the equation of the line that passes through the point minus 5, 11 and has a slope of 1 over 7. Okay? All that's really happening in these problems is that our numbers are getting a little crazier. Like having a 7 on the bottom just makes it messier, but the process is exactly the same. We take y equals mx plus b. That's our equation of a line. We plug these points in. Remember, this is x, this is y. Now we can plug everything in. 11 equals 1 over 7 times minus 5 plus b. Right? Now we are going to have to, this is going to become minus 5 over 7. So we're going to have to add 5 over 7. And we'll have to do that to both sides. Right? First you do this multiplication, you find out what you've got, then you add or subtract the opposite because we're trying to isolate our b. I'm adding 5 over 7 to both sides. The 11 needs a 7 on the bottom, so this is going to become 77 over 7, right? I multiply top and bottom by the number I want. This is the least common multiple. I add, this cancels, I get 82 over 7 equals b. See, that's kind of like a big, crazy number, isn't it? But it's okay. So now we're ready to write the equation of our line. Again, we're using this as our format. And we write y equals 1/7 x plus 82 over 7. I like this presentation. I like to have the fraction separate from the x, but sometimes you'll see this written as x over 7. See how they just multiplied those together? This is fine, but again, I like this better because I like to see the slope standing strong and true. Sometimes students ask me this question: do they need to have matching denominators? No, they do not. It's perfectly fine if the denominators are different, like if 7 would go into 82, we could divide it. That's fine. They don't have to match. Okay, so I'm drawing a box around this one because I like it better. This one's okay. Again, I multiplied the x times the 1. We only do that when there's a 1 in the numerator. I don't like it. I'm a purist, you guys. I like my slopes to be strong and independent. All right, and the last one, find the equation of the line that passes through the point. Oh, look what John's doing. The numbers are getting even bigger, but it's okay. Oh, this is 4D, not 4. And the slope is minus 1/2. Okay, same process, exactly the same. Honestly, I don't know why he has so many examples of this. It's kind of overdone, but that's okay. We're having fun. We don't care. We'll just do these examples all day, won't we? Example 107.42. You wouldn't be mad, would you? I know, neither would I. Okay, let's plug in. 40 equals minus 1/2 times x, which is minus 50, plus b. Remember, we're solving for that, so we're going to simplify this and then subtract it to get it to go to the other side. Swim that fishy. All right, are you ready? Me too. So there it is. This multiplies together. We get a positive 50 over 2. Aha! 50 over 2 equals 25, doesn't it? We can simplify this fraction. If you can simplify, feel free to do it. So now we want to subtract 25 from both sides. Oh, this one's nice because it turned out to have whole numbers, didn't it? Okay, so this turned into this. We reduced it to this, and then we subtracted it. This cancels. 40 minus 25, oh, that's 15. And that equals, see, there's my equal sign, b. All right, there's our m, there's our b. We're ready to write it in this form, and we write y equals minus 1/2 x. Again, some people would take that x and put it up here. If there's a 1 in a denominator, some people like to squish it. I don't. I would never mark that wrong. You would never lose any points over that, but I don't like it. I think it just muddies the water. Okay, plus, what's our b? 15. Guess what? Is that the right answer? Yes, that's the right answer. Another just little stylistic issue. This is one of the very few times when I'm willing to kind of float that x. The 1 and the 2 are clearly numerator and denominator. I like to kind of float the x in the middle. It just highlights to me that this is a slope, and this stands alone and has an important value in and of itself. So that's why I float that. I'm also willing to float a b. It's a stylistic issue, but I think it's fine. I kind of like how it looks. Yay! Okay, so let me just show you in the homework. For the practice problems, John is going to give you 2 problems where the slope you need is given in a way that you have to figure it out. Here's a parallel line. This one's been rearranged, right? We can see, oh, look, the slope's right there. It's minus 3. So our slope will be minus 3. This one is like the example I did where John gives it to us in standard form. We have to rearrange it to y equals mx plus b. Then we can take the slope out. Then we can use the point to solve. These second 2 are the easy 2 where he just gives us the slope, and that's that. Okay, lesson 107. Yay, done. Goodbye.